slide. Look at that. See, that's magic. Actually, panini is what we now refer to as the pandemic. So all of those that were starting to get hungry, I'm sorry, really, you'll have to put up with this. So we're going to talk about some of the different software delivery principles that we have kind of learned through the pandemic and how we can make some better high performance teams. So software delivery itself has never been more critical to the success of business in every industry that we see. So everyone's a tech company now. It's also never been more complex as we think about software delivery. A lot of the expectations that we have for delivering high quality software incredibly fast have skyrocketed. So, yesterday's more kind of exceptional product experiences are expected today to be more beautiful, intuitive, powerful, and affordable. But the landscape of tools, platforms, architectures is constantly evolving. This is just the CNCF landscape, and it grows constantly, and you can't even read any of that. You might recognize a few of the logos. But with this rapid pace of change and the growing challenges that we see with all this complexity, how can engineering teams not only succeed, but beat out the competition? So often when we kind of take surveys, we fall into the trap that John Allspaw once tweeted of work is imagined versus work is done. The top being basically our plans, the thing we think about we're going to do, and then the bottom piece of that being really how we kind of get there. Or as we kind of call it, performance described versus performance derived. So given that our platform is used to perform many of the activities that are associated with high performance teams, it allows us to measure the actual behaviors that get performed to get a better understanding of how actual engineering work is being done and being pushed through their CI/CD pipeline. Like, did they actually push code as often as they thought they were, as they claim they did today, or was it really just a couple different things, or how long are their workflows actually taking? So as I said, I'm Jeremy Meiss. I'm the director of DevRel and Community at Circle CI. We are a cloud-based and on-prem CI/CD solution. We've been around 10 years. That's all you'll hear on that. So you can follow me on the Twitters, and I disavow I don't take any responsibility for anything you read. I can't even remember half the stuff I say after I say it. So, all right, so before I go any further, I want to kind of call out the state of DevOps reports. They're extremely important to the industry. They've helped to shape a lot of the trends and behavior and practices that we've seen. They're highly valuable in how we understand what a high-performing team looks like and getting to accelerate. The big difference between the report that I'm going to talk about now that we have been doing over the last 3 years and this one and the state of DevOps reports, which have been going on for quite a while now, is that that report is based on survey data. So how people are remembering and kind of how they're answering the surveys, which have been done very, very well to try and eliminate a lot of that bias. But also, you're still based on the memory of the engineers who take the survey. So at Circle CI, we have massive amounts of unique data on how technology delivery teams are actually, kind of behaving in the wild. We started looking at all this data back in 2019, published a report, and then 2020 came along, and we saw that, as the world was changing, we saw a completely different type of data start to emerge as people started to stay more at home, how developers were working. And then in this year's report, 2022, we kind of pivoted to encompass a larger data set since we wanted to encompass include in that data set stuff from development, from things that included the pandemic as well as a little bit before, and then as we're still in it, and then kind of come on the tail end. So this report for 2022 has over 257 million workflows that have been analyzed, over 44,000 organizations, over 290,000 projects, and it actually ends up being about over 1,000 times bigger than any of the others. And we don't believe in kind of the one-size-fits-all success metrics for delivery, because every team's different. I'll say this a few times, but you are not the Googles, you're not the Netflixes. I mean, you might be. Netflix might be here, so hi if you are. But generally, you're not like them. You have your own business, and you have your own product that you're shipping, and the complexities that come with that. And so, as we look at kind of the delivery patterns and kind of understand what top delivery teams look like, it's going to be important to kind of keep that in mind. Is this has to be tailored down to you and your business. So one of the big things that we kind of offer was kind of this set of baseline for the 4 metrics that typically are related out there. The classic metrics for software delivery is deployment frequency, lead time to change, your change failure rate, the recovery from your failure time. We took all of that and we kind of looked at everything within the data set and kind of came up with what are the big things that relate to CI itself. So the benchmarks we identified for high-performing CI are with throughput. That's going to be the average number of workflows that are run per day, and that is the suggested there's merge on any pull request. Just merge. For duration, the average length of time for a workflow to run, and we say that should be 10 minutes or less, as we've identified high-performance teams. Mean time to recovery, which is the average time between a failure and the next green build or the next success, should be under an hour. And then success rate. That's the number of successful runs divided by the total number of runs over a period of time. And for that, 90% or better on the default branch. And we'll touch on why, when we get to the success piece, we'll touch on why default branch is so important there. So we've been publishing this report, like I said, for about 3 years. Pleased to say that more teams than ever have started to show up as part of, are hitting these benchmarks of what it looks like for a high-performing team. This means that more teams have been identified as delivering their software successfully at a high velocity and is that competitive differentiator for their product. They've also prioritized these key principles and components to hit this goal. And by hitting these different benchmarks that we talk about, these high-performing teams like this one are getting maximum value from their software delivery pipelines. This is also how some people's merge process looks like. There we go. All right, so let's jump into the data. The throughput. Throughput is the average number. So I said it was the average number of workflow runs per day. So workflow is generally triggered when a developer makes an update to the code base in a shared repository. They push it to the version control system, also called VCS. So that'd be anything you might be using for version control. And that triggers a CI pipeline that runs that workflow. So large commits tend to get pushed less often. So a lower throughput may indicate that your commits are quite large. And when it comes to the size of the commits, you really want to make sure that it's containing a meaningful amount of change without being too small. I know that doesn't give you, it should be 100 lines of code or 1,000 lines of code. But if you think about it, like the whole goal of CI, continuous delivery, also is to get to like a meaningful result, getting to kind of that signal of what's actually happening with your builds quickly. So if the quicker you can get the smaller bits of code to troubleshoot, the better. So it's a lot easier to troubleshoot through 100 lines of code than it is from 1,000 lines of code off of a commit. Throughput also is going to vary greatly depending on the needs of your business. And it also is going to depend on the duration and mean time to resolve for you as well. So if your pipeline takes, say, 8 hours to run, that's your duration, then you're only going to be able to complete 3 workflows per day in throughput. 8 times 3 is 24. You didn't know you're going to have to do math today. But I'll do it for you because I'm that kind of guy. All right, so 50%, as we looked at the data, so 50% of the workflows in the data set were run less than once per day. And that was like 0.7 times per day on average. But at the 95th percentile, that includes workflows that were run over 35 times a day, or about once every 45 minutes throughout that whole 24-hour period. Now, your software delivery cadence, again, is something that has to be built on your business needs. Making changes to your project with an automated testing workflow means that your organization is no longer blocked by waiting for manual quality assurance to happen. PJ talked about the importance of QA. All of that's contained in that, so you're not going to be blocked by it. And by having everything fully automated in your software delivery pipeline, it's up to you how frequently and when updates are delivered to your end users. So with many of the percentiles, when you look at on the way the dates line up, you saw a slight dip as the pandemic was hitting in early 2020. And then the maximum here was reached in about April of 2020 across the board. And this does make sense when you're thinking about in the global uncertainty that we had. We saw that companies were taking their engineering teams, shoring them up, giving them, hey, we got to get as much fixed as we can because we don't know what's going to happen, and automate it as much as possible, and getting fixes in, and so throughput was going up and going higher. So again, looking at that was also that time frame was a primarily like lockdown mode across much of the world, and so a lot more code was actually going into the system. We saw a lot more activity that was happening when we hadn't before during certain time frames. So like before an average day, it had been about 11 or 12 hours where CI processes were happening. That jumped to 14 hours per day. And that could be reflected when you think about you as a developer, no longer sitting in a commute. You're now at home. You're able to get up early or get up late or just respond to things, not have to sit in a car or on the train for 2-3 hours a day. So being able to see this, the data kind of helped us understand that. And most projects just are not deploying dozens of times per day. They're not even validating their software dozens of times per day. So while it's not untrue that a description of a high-performing team is one that deploys a lot of projects, it just means that it may be that one project that really is moving that fast, but the rest of the projects the teams are working on aren't really. So looking at the total sample that we were able to do, of everything going on within that engineering department kind of helped us understand that, it really was multiple, a particular number of deploys per day is not really the goal, but continuous validation of your code base via your pipeline is. I'm just going to stop using that. Okay, so duration. So duration is defined as the length of time it takes for a workflow to run. It's one of the most important metrics in this list because, we talk about creating fast feedback is so important to your CI and being able to fix the issues. And so that includes your throughput and your mean time to resolve, your mean time to recovery. All of that hinges on duration. So, if your failed big build signal gets to developers, but it's going to take you 3 hours to fix it, then that means that it's going to take you that long to find out if that build fixed, or the fix you just put in, whether that actually resolved it or not. So it's important to understand that duration of your builds is extremely important to high performance. So looking at December 2019, so on the earliest here, through September of 2021, which is the last period that we did, so about that year and a half, durations increased across the board. And this does make sense because as teams are becoming more and more mature with their applications and their DevOps maturity within the platform, they're understanding, doing more rigorous testing, increasing the use of, different tools, third-party tools that helps them validate their software. And this is going to take place and seeing more, the workflow's taking a little bit longer, and that's okay as long as you're doing that testing, as long as you're making, automating where you can and filling that in. And we see that staying pretty consistent. The median, though, here puts us right around the 4-minute mark. And as a developer, if you're getting good, valuable feedback in 4 minutes from when you just pushed your whatever that that commit was, that can be a game changer for you and your development teams. The 95th percentile, though, was at 34 minutes. And so, for a lot of companies, and that does depend on what's being built, we see that, what the test scenarios are and whatnot. That 34-minute mark is probably a good spot to start with. With duration, we see that the mean fell heading into the pandemic, and then it stayed steady. But the 50th percentile and above dipped, 50th percentile and above, the duration increased year over year with kind of that slight dip in April. And then it continued to increase again. One thing we also saw is duration on default branches was faster at every percentile over the non-default branches. And so this is telling us that the mainline branch people that are working in just the mainline branch are making sure that everything is functioning on your default branches much faster and limiting the time of making sure feedback is good, limiting any issues there might be. Okay. Mean time to recovery. I feel this is the important metric on the list so far, overall. The ability of your team to recover as quickly as possible when an update fails, time and time again, is going to be that ultimate goal of agile development teams. The more robust testing and corresponding output you're going to get from that testing, the faster it is to resolve issues and fix those errors that get introduced into your code base. So because MTTR improves with more comprehensive test coverage, this metric can be used as a proxy for how well tested your application is. Although it's important to note that error messages, they do play a vital role and should be called out specifically. So you do want to get that, look at those error messages, but it's understanding how well tested your application is makes a big difference. The shortest your MTTR can be is equal to your duration. So if it's 8 hours or 8 minutes for your duration, you can't get to a recovered build any faster than 8 minutes. So that just kind of makes sense. Now you will kind of see an instance where you have a run results in a failed state. Developer immediately knows the solution. Maybe it fails immediately. They know what it is. They immediately push the fix, and so there's that instance where you get to a green build quicker because it failed right at the beginning. But generally, that full successful run is going to happen as long as your duration is. Now, Brandon Byers at ThoughtWorks, he told us in our report that the importance of build health was paramount to ensuring a steady delivery cadence. And his thing he called out was the quickest way, when you think about a broken build, you've just committed something that broke your build, instead of spending the hours to try and fix it, the quickest way to get back to a working build is just roll back the previous commit. Don't keep things red. Get back to the green, figure out what went wrong, and then fix it. So it's a great quote. Hopefully you read that. I'll share my slides later. So in the 5th percentile, we see pretty consistently 2 minutes that it kind of sat in a failure state before it was recovered. A lot of times in those scenarios, that's probably you're seeing multiple contributions running, like I mentioned, where developer 1 pushes a bad commit. Developer 1, developer 2 goes, that's what he screwed up, fixes it. Bad commit failed really quickly, but then the new commit came along, succeeded right afterwards. It also could be the same developer. If you look at my commit history, that explains all of that. But at the 50th percentile, you're seeing about an hour until it's recovered properly, which is an improvement of about 3 minutes over our previous reports. And then from there, you start to see codes getting pushed. You go home and come back the next day to check it. People just really living on the edge there. The mean here, though, is that's about the 14.85 hours. And that kind of makes sense with this whole pushing the code and then going home. Because, that is about the end of a workday to the start of the next. But at the 90th percentile, and 90th and 95th, it looks like people just really go home. It's a long period of time. It's about 3 days, sometimes a weekend. But we're seeing improvements. And so with this kind of going home bit, that does kind of make us think about, that's branches that doesn't really matter. That's the code you're working on for the weekend or through the week, and it's maybe one of your innovative kind of branches. You're trying out new features, and you're just going to run it, come back over the weekend, or come back tomorrow and fix it. It's not as important. It's not your main branch. It's maybe a test or a feature branch. So in the 2 years as we've been looking at this data, we've observed that MTTR, if you look at that big jump, what time of year does that correspond to? It's the holidays. And annual cycles in the market and the predictable rhythm of seasons kind of creates more powerful impacts on engineering. And so MTTR, and as we went back and looked at all the data, it's all consistent. The biggest impact to your ability to solve issues is over the holidays. So that puts small developer teams at a real disadvantage. We've seen, this is due to large parts in reduction in staff, while organizations are hopefully encouraging a good work-life balance. And that's why a lot of companies, though, now put a freeze on any code-based changes over the holiday, unless it's absolutely necessary. And so as we continue to see here with the recovery time, it's the same basic path from the other metrics, is that they're overall kind of declining. In the 95th percentile, we're seeing the year-over-year drop, but a big drop in April and May. It's generally reflective of, if stability is going to be the business's ultimate goal, then, those commits that you're pushing during that time are going to reflect it. So what we saw in the early stages was, this all hands on deck, early stages of the panini pandemic, is that, ultimate, all hands on deck mentality. And so everybody was getting there resolving issues in kind of this feedback cycle. So there was the red, green, or red in space of, in case of some code. And all of a sudden you get the green. That's this idea of trying to get to ultimately the end goal of getting everything back to green. All right, success rate. So this is the one, this is the number of passing runs divided by the total number of runs over a period of time. So we're looking at, how often does your pipeline complete with a green status? A pipeline can complete with either red, green, or error. And error just means kind of incomplete, something couldn't be done. So the success rate for any given project is not particularly interesting without knowing, how does your team do with your kind of Git flow model? Are you using feature branches? Are you primarily pushing everything on your features and on your topics, and then when everything's good, then you move it to production? Are you just throwing everything to the wind and just do only in production? Who knows? But that takes the success rate is very important. So for us, we're really only concerned about the default branches, making sure that the success rate there is high, because the reality is that if you're doing a lot of innovation, then the success rate on those non-default branches should be low. And it's okay to fail. It's okay to have a low success rate on those non-default branches because things are going to fail. You're trying new things. It's okay. A healthy development team is one that operates that way. Okay, so looking at all of these here, this is kind of as we look through 2019, 2020, and then this year, the benchmarks. We're seeing that things are increasing on the duration. The median was 3.7, which is less than what we say is 5 to 10, so that's good. The time to resolve, 73.6 this year, which is high, as opposed to the previous years. That also comes in effect of this report encompasses the whole time from the just before the pandemic until September. And then success rate is going up on the default branches. We also saw a lot more development starting to happen on the non-default branches than before, which is a good change and reflects kind of this mentality of not really concerned about the success rate on those. And then throughput, even with all of the ideas of, hey, we got to push tens of times per day, the throughput was on average, the median across the board was 1.43 times per day. But that should be as often as your business needs. All right, how much time more time do I have? Okay, cool. So I'm gonna go through a couple things real quick. Spent too much time on the others. Don't deploy on Friday, it's not a thing. No matter what Twitter tells you, it's not a thing. Deploy, no. If your code is correct and if you followed all these principles, you should be able to deploy on Friday and it be fine. The reality is the data shows that Friday is just as much of a deploy day as any other day. No matter what they want to say to you. Language shifts over the last few years. So we've seen JavaScript continues to be top, Ruby, JavaScript, Ruby, TypeScript, Python, still top up there. Go continues to it's come up. Some others that are making the list are like Rust that comes up. Dockerfile is one that's used in CI. Gherkin, I don't even know what Gherkin is. You have some others that just kind of stay consistent across there, but it's an interesting look. Other thing here with some of these durations, those files or languages that don't really have any build steps, they just finish really quickly, are at the top. Many shell scripts run exit without a whole lot of robust testing. What's interesting is Go is up here as actually, it's a compiled language, but it finishes up here, with a lot of those that aren't, mostly scripting languages. Meantime to resolve, again, those that don't have a lot of build steps, quick to get, but Go's there at number 4 as a short time to resolve. Success rate, again, with mostly things that don't have a lot of steps, Go continues to be up there high. And seeing some other things, Java's up there on the success rate. PHP, Python are all kind of up there. Go again is just kind of this outlier with a lot of like dynamic languages. And whereas, things that have a lot more of build steps, especially have to be compiled. And then throughput. Hack is up there. I forget which one. Hack itself is, kind of says that it's meant for fast development and fast throughput. So it shows up high. And then you got some others here, starting to see things like Apex, which I think Apex is Salesforce. So that's starting to appear more as people are starting to do more with that. Closure continues to be up on that list. Vertical splits across the data, just some interesting healthcare duration. I'll share these out, you can see. The other thing is going back to the State of DevOps reports. They, every year, kind of identify what does a high-performing team look like. What's been interesting is seeing that, on our platform, the 50th percentile of users consistently hit year over year this kind of elite deployment. They're the ones that are doing it on demand, and they're doing it less than an hour and all of that. So last bit here, if you want to see the full report from 2020 or this year's report, both of them are there. Like I said, I will share this out with the DevOps Birmingham hashtag. But yeah, definitely, you don't have to download a thing. You do have to download it. You do kind of want to download the report. You don't have to sign up or anything. You don't have to fill in your name, email, any of that. You can if you want to, if you want more info, but this is a great way to just get the report. Hopefully you got that gone. And that's it. If you have any feedback, I'd love to hear it. You can go there, circle.ci/Jeremy, and maybe get some swag. Or if you just want swag and don't care about the feedback, I prefer that, but whatever. So yeah, thank you.
Thank you, Jeremy.